Hello and welcome to our adapter pattern presentation by Michael Hegerhorst and LaRee Scott. Today we're going to be talking about the adapter pattern, which is a pattern of programming that is used to connect two existing components together so that they are still compatible with each other.
These components would usually be in the form of incompatible classes where one class provides an output that is not in the correct format for the required input of the second class.
The adapter pattern is primarily used so that old systems will work with new interfaces and new systems.
The adapter pattern is similar to the bridge in that it provides an interface between components. However, the bridge is designed in advance so that the separate components could be programmed independently, and the adapter pattern is programmed as a retrofit for existing components.
A really good real-world example of an adapter pattern are sockets. Around the world, there are many different types of sockets that you might encounter. And if you go from one country to another, you would need to get an adapter so that your electronics will be able to plug in and receive the correct voltage from the plugs. If you don't do this, then either your plug won't fit or you could damage your electronics with too high voltage.
A software example would be two incompatible media players. As you can see here, our simple media player has a play function, and the advanced media player has play functions for more advanced, more recent current file types like VLC and MP4. So if we wanted to use them together, we would have to create an adapter interface.
A full adapter diagram might look something like this. We have our media adapter and we have our advanced media player and our normal media player. These two are hooked into each other to create the media adapter, which the audio player then uses in order to play all the audio that it needs to be able to play.
First step is to identify which classes you're trying to use that are incompatible. Then you take the output sent by the first class, and look at how it's different from the input required. And then you can use that to design your wrapper class so that you can adjust your output to the required input. And then as part of that process, you have the wrapper class has an instance of the adaptee class. And the wrapper class maps the interface to the adaptee interface. And then you program your client to couple to the new interface so that everything can run smoothly. There are several advantages to the adapter pattern. The first advantage is that it's simple to use without breaking your existing code, because you don't have to alter what you've already done, you just create a separate interface. Also, it allows you to reuse your old code rather than having to recode things over and over again just because they're slightly different than you originally coded. And finally, it helps with modularity because you can keep your interface code as separate from your original classes, and you're able to adjust as necessary.
Unfortunately, there are also several disadvantages to the adapter class as well. The first is that they can be complex to create. If there's a very complex class and the classes are very incompatible, then it can take a while to develop an adapter that will work between the two of them. A second is that it will increase code complexity in the future. As you create more adapters, the adapters will become more and more complex, and there may be more steps involved in order to use them correctly. Additionally, it increases the bulk and the overhead of the program. It can take more RAM when you're using an adapter, and it can also increase the file size of the program. Finally, it results in something called adapter chaining, where you create an adapter, and then later on down the line, you have to create an adapter for that adapter, and then farther down the line, you have to create an adapter for that adapter for that adapter, and so on and so forth, until you have so many adapters that you don't even know what you're going to do with them.
The adapter pattern is very similar to several other patterns, so we thought we would explain the differences. The first is the bridge pattern. As I said before, the bridge is designed in advance of your classes, and so that your classes can be developed independently, whereas the adapter pattern is after the fact to retrofit existing classes.
Another similar pattern is the decorator pattern. Instead of creating an adapter between two classes, as the adapter pattern does, the decorator pattern essentially puts on a new coat to an object. It doesn't change it, it just enhances it.
We also have the proxy pattern, which provides the same interface instead of creating a different interface like the adapter pattern does.
Finally, we have the facade. This one creates an entirely new interface instead of attempting to adapt the old one.
Thank you for viewing our presentation on the adaptive design pattern. If you're interested in learning more information, here are our lists of sources.